Welcome tutor. Today we're going to be looking at the products from oil topic of chemistry unit 1. First, let's look at thermal cracking. Thermal cracking is converting long chains of hydrocarbons. What's a hydrocarbon? A hydrocarbon is a substance made of hydrogen and carbon only. So long chains into short chains. So this is one long chain, and then if we go through the process of thermal cracking, it will convert this long chain into many short chains. To do this, we need heat, a very, 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 very high temperature. Say 900 degrees Celsius. And we need a catalyst. An example of a catalyst we can use for thermal cracking is porous pot. And we need no oxygen. This experiment, this reaction, that cannot take place if there is oxygen present. So we have to have no oxygen. Oxygen must not be present in order to convert the long chains to short chains. Next. Okay, so why do we convert the long chains into short chains? Why are we doing this? Because it's basically to do with demand. We need more short chain hydrocarbons like petrol and less long chains like wax. Now in thermal cracking, ethene is also produced. Ethene is an alkene, ene. And an alkene is a hydrocarbon with a double bond. An alkene is also unsaturated. What does unsaturated mean? It means that something can be added to the double bond. How do we test for an alkene? And to test for an alkene, we use either iodine or bromine. Iodine is purple in solution, and bromine is orange. If an alkene is present, then the solution, if we add the alkene to it or the substance we're trying to test, and the bromine or the iodine turns colorless, then an alkene is present. Not clear, not white, it turns colorless. Clear means you can see through it. So, how does this actually work? Well, as we said, unsaturated, so you can add something to the double bond. So if we add iodine or bromine, this happens. Or with iodine, depending on which one you added. And that shows that it's an alkene because you've added something to the double bond. And so therefore it's unsaturated, therefore it is an alkene. Next. Okay, so in polymerization, we convert monomers into large polymer chains. So here we have a monomer, for example, ethene. And we convert it to a polymer, which is called polyethene. So naming it is easy. Just put poly in front of the monomer name, and that's how you name it. The harder part is drawing the structure of a polymer. And I have seen many questions on this. So first of all, you see the double bond, you have to open the double bond. Open it. That's your first mark. And then you have to put brackets. Doesn't matter if they're square brackets or normal brackets. And then you put an N. The N means this a certain number of times. So this is repeated a certain number of times. If you memorize that, you'll be fine. Let's do some more just to practice. So here we have the monomer styrene. And you should know that monomers are always alkenes with double bonds. Now, let's draw what we call the repeating unit. So first of all, you have to have a single carbon-to-carbon bond. That is your first mark. Then, you extend the bonds with the brackets. That will be your second mark. Then, of course, the N. That will be another mark. The N and the brackets, that shows a repeating unit. What do you mean by repeating unit? Well, because the N means this thing is repeated several times because polymers are long. Say you have many individual monomers and you connect them into one long polymer chain. It's going to be a long, long chain. So that's why we just break it down to a snapshot of the polymer. And this snapshot of the polymer is called a repeating unit. Now obviously, to get the last mark, you have to draw the structure correctly. So the hydrogen bonds stay the same, and so does this. So don't be put off that this is not just one hydrogen, because it's going to be the same, drawn the same way as the others. Now for this one, this is chloroethene. Remember, monomers are always alkenes. So what do? We draw the structure first, carbon to carbon single bond, and we extend the bonds. The bonds have to be extended through the brackets in order to get the mark, and they have to be coming from the carbon. They can't just be drawn here or anywhere. They have to be coming from the carbons and extend through the brackets. And then you, and then you put your N, which makes this a repeating unit. So polymers, what the hell are polymers? Polymers are basically what we refer to as plastics, and they're very useful because scientists can design them in a way that allows them to be very useful for specific functions. And they've got many special polymers. In the exam, they will not ask you on specific ones for factual recall, but they might give it to you in, say, a case study format. So I'm going to go through some examples very quickly. UV glue for non-hurting plasters. It becomes less sticky when UV light is shone onto it, and the outer layer is removed, and the sunlight then causes the plaster to fall off. These are what we call light-sensitive polymers. Also, we have dissolving polymers, like in medicines, polystitches, which naturally dissolve in the body, and PLA, polylactic acid. This polymer is made from starch or corn and is sustainable and renewable and is biodegradable, which means it can be broken down by microorganisms. And the main disadvantage with polymers is that most of them cannot be broken down, but some of them, like PLA, can. And so they might, in the exam, they might ask you questions on this, environmental advantages and environmental disadvantages. Next. Okay, so the last part of this topic is ethanol, and really it's how to make ethanol. First of all, ethanol is a biofuel, which means it is sustainable and renewable. Ethanol is made by two methods, fermentation and dehydration of ethene. We're going to look at fermentation first. So fermentation, first you have sugar. And sugar is usually mixed with water or dissolved in water. And we use yeast or other enzymes, and maybe 37 degrees Celsius or 40 degrees Celsius, within that range. It's going to give you ethanol, but it's also going to give you carbon dioxide. So the hydration of ethene. Now look at the name, hydration. You should immediately know that water is involved. And it is involved, but in the form of steam. So you have ethene, then you add steam, react with steam to give you ethanol. And as you can see, the oxygen and the hydrogen from the water, or steam, has now bonded with the ethene to produce ethanol. What are the conditions you need for this reaction to occur? You need pressure, you need a catalyst, and you need a high temperature. Now these two methods of making ethene, fermentation and hydration, of ethanol, fermentation and hydration, you need to know them because it comes up regularly in exams. So you're going to lose a lot of marks. Now I'm going to talk about the advantages and disadvantages of these two methods. Okay, so fermentation is cheap. It's cheap to grow the plants. And hydration of ethene, it is expensive. Why is it expensive? Because you're using high temperature, you're using pressure, blah, 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 it's expensive. Fermentation, it's renewable and sustainable because you're using sugar, you grow it. And hydration of ethene, it's non-renewable because ethene comes from crude oil, and crude oil is going to run out eventually, so it's non-renewable. Fermentation is carbon neutral. What is carbon neutral? Carbon neutral is, say if you're growing the plants, it takes in carbon dioxide from the atmosphere through photosynthesis, and when the fuel is burned, it releases the same amount of carbon dioxide. So the carbon dioxide levels in the atmosphere, they do not increase. It takes it in, releases the same amount. So no increase. But for hydration of ethene, when the fuel is burned, the levels of CO2 do rise. Only fermentation is carbon neutral, but both of them release CO2 when the fuel is burned. Fermentation is slow. Growing the plants is incredibly slow, and also, the time you grow the plants, blah, blah, blah. And the hydration of ethene is a fast reaction. Fermentation, it produces impure alcohol, and usually, on average, only 15% of the product is alcohol. But hydration of ethene, pure alcohol. So these are the main advantages. And obviously, fermentation, land use. Land use is a big problem. You're growing the crops for fuel, not food, which has some ethical issues, as well as food prices may rise. Also, you have to separate the alcohol from water, and you have to use distillation for that, which may be quite expensive. That's it. Bye.